Welcome back to the 4911 Cyberknights software training. We are going to talk about classes today. That's what session 7 is about. It's classes, all about classes. But first of all, a review. The last session was all about arrays. We started with some pretty, with basics concerning arrays. We talked about how to construct them, how to access them, reading and writing to them, what random access means, the methods that you can use on an array, how an array works with the for each loop in Java, and then certain limitations of arrays. And then we moved on to advanced arrays, where there was a live sample where we shifted values around by one. I showed a special syntax for initializing an array, how arrays can be used in the Java class libraries, and then the subtle differences for how arrays work when you fill them with objects versus when you fill them with primitives. And then the last subject on the slides was multi-dimensional arrays, where things got a little bit complicated and weird. Firstly, rectangular two-dimensional arrays, which are basically tables, not too complicated, but still a little confusing. And then jagged arrays, where each entry can be of a different length, and that's where things can get kind of confusing, and you really got to be on your game to keep track of things. And then there was an example at the end where we just went through and wrote a program that would track the hours of an employee. Today, like I said, we're going to talk about classes, and our agenda is that we're going to start with object-oriented concepts. And we've used this concept, or this phrase before, object-oriented, without really nailing it down, what it means. Today we're going to get into all about objects. We've talked about objects in the past, but you can't really talk about classes without talking about objects in depth. And then we'll talk about the different aspects of objects, what they have. Objects have state, and they have behavior, or you can call that fields and methods. And then we've already created objects in the past, but today we're going to show how to make a way of creating your own object types, and that's via constructors. And then we'll talk about a concept called encapsulation, where we hide the inside of our objects while exposing something to those who use the objects. And then instance methods, and then a new keyword, which is this, THIS, that's the new keyword. And then we'll close by doing a coding example. Great. So what is object-oriented programming? Object-oriented programming is just talking about a program as a set of objects rather than a set of actions. And then, that kind of forces us to really define what an object is. And objects are entities. They're like things. Entity is just a fancy word for thing. Things that contain two categories of stuff inside of them, and those two categories are state and behavior. Okay, great. So let's ask the next set of questions. What is state and what is behavior? Well, state is a set of values. So this is like data or information stored inside of an object. Behavior is stuff that can be done, actions that the object can perform. And very often when you're talking about those actions, you're either reading from or writing to the internal state of the object or the fields. So another way of thinking about this is that state is like the noun part of an object, and then behavior is like the verb part of the object, where state is what it has, and then behavior is what it does. All right, so let's move on to a new definition for class. What is a class? Well, from the very beginning, we had to talk about classes because in Java, everything has to go in a class. All your code has to sit inside of a class. And so our basic definition was that a class is a basic unit of code. It's a container or a wrapper for your code. But the actual definition, or I guess our more in-depth definition of a class, is that it is a template or a blueprint for making objects. So there's this relationship between classes and objects, and it's really important to keep this different because they're not the same thing, and it's easy to confuse yourself if you're not really clear and you don't really clarify your thinking on this. And the relationship between them is that classes define objects. So they define the different things that go in the objects. In the classes where you're going to define what sort of state, behavior, and what sort of constructors your objects have. Objects are instances of classes. They are not classes themselves. They are instances of classes. Okay, so let's move on to the first part of what classes define, the fields. The fields are, a single field is a variable, and we worked with variables in the past. We know how those work, but it's a special kind of variable that lives not inside a method, but it lives in the class itself, and it makes up part of its internal state. when we're talking about variables that are part of a class, or that are defined by a class, we talk about instance variables. And that's sort of the terminology we use to separate them from variables that would be defined within a method. These are not the same as regular variables, but they work similarly. So looking at this definition right here in the middle of this slide, we have a very simple definition for a class, and the class is called point. And we used the built-in point class definition previously for Java, but here we're writing our own. So let's just say we're writing our own point class. We don't want to use a built-in one for Java, or maybe we're in a universe where it doesn't exist. And so what's useful for a point to have? Well, points should have, if they're going to be on a graph, they should have an x value and a y value. And so you can define those values inside the class itself. These are not part of a method, they're on the class. And you can see that they're very similar to how you would define a variable inside a method, where you have the type and the name. We have the type for both of these int, and then the name of the first one is x, the name of the second one is y. Those are variables. And when you define them on the class, that means that every single object you create from this class is going to have its own x and y. And another special way that these fields work that's different than regular variables is that they will have default values. So you can see here that I'm not setting x equal to anything or y equal to anything. I'm not assigning values to them. But when you declare these instance variables, they will get a default value regardless. And the default value for primitives is going to be, well, it depends on the primitive, but for an integer, it's going to be 0. So even though I haven't said x is 0 and y is 0, they are 0 when I declare them in this way. So how do we use fields? Fields, the way that you access the field of an object, or I guess rather a field that's declared on a class, is that you have to create an object from that class. And we've done that before. We use the constructor syntax, where we use this new keyword, and then we call the constructor, which is the same name as the class. So this is, our class is point with a capital P. So to call the constructor, we use that same word with the same capitalization, and then it has a constructor where that takes no parameters. So this creates a new point object from our point class, and then we're assigning it to a variable called P1, and the type of P1 is point. Okay, great. So we've created a new point, P1, and then to access those variables, those fields inside of P1, we just say .x or .y, but we have to refer to it, the object name first. So P1.x, P1.y, and then you can write to them, you can read from them. Here I'm writing to them. Likewise, if I was to create a second object, it just has to have a different name. And then to access the fields inside that particular object, P2 instead of P1, I have to use the P2 variable name .x, P2.py. So these are different points. Each of them have their own x and their own y. And by writing to x on P2, I am not writing to the x of P1. Those are different objects. They have different x's and y's. And you can do the same sort of things if it's an integer. In this case, you can do the same sort of operations that you would do to an integer that you declare in a method. You can use plus equals if you want to add 11 to whatever x currently is and then reassign it to x. You could use p1.x plus plus, minus minus, all the normal integer operators would work here. And likewise, if x and y were doubles, the same rules would apply. Okay, so instance methods. So a method, we've talked about fields. Methods are behaviors. And an instance method is something, it exists inside the object. And each object from that class has its own copy of those methods. The methods will work on the object, not the class. So in this case, I've expanded my definition for the point class and added this translate method. Translate, you can think about this as just like moving a point on a coordinate system, and it takes as its parameters dx and dy, which would be like delta x and delta y. And so we adjust the x position by delta x, we adjust the y position by delta y. That's what the plus equals does. It adds dx to x and reassigns it to x. The instance methods can access the internal fields. So you can see that this x right here, I haven't declared it because it exists on the class itself. This x, when I say x plus equals dx, I mean this x, and Java knows that that's the x I'm talking about. Instance methods are not static, and static methods are not instance methods. They have to be one or the other. Static methods exist on the class, and there's only one copy of them. So every time you call a static method, you're calling the same method. But every object gets its own copy of instance methods and fields. So when you call a method on an object, you're calling the method on that object, not the one that exists for the class. This is a little confusing, but like I said, this is really important to sort out because it gets even worse later on if we don't understand it now. Okay, so another, as I guess I kind of already went over this, but when I'm accessing the X and Y for this point class, I don't have to use the object name. I can just use the name of the object that we're currently in. I can just use the variable name. If I was outside the point and I was trying to access X and Y, you remember what we saw on the previous slide where it was p1.x and p2.x and p1.y and p2.y. Here we don't need to do that. When you're inside the class definition, you can access those variables directly. And furthermore, like if you were required to use the name of this object, the current object that you're in of this class, well, what is the name? We don't know inside the class because it hasn't been created. We're declaring like how the object should be made, but we haven't created one. When someone creates the object, they give it a name, so we don't know what the name is. And that's why it's okay to just use those variables directly without using the object name P1 or P2. But there is a parameter there, so that when we're saying like X and Y, you can imagine like there's a ghost parameter in front of it, and then it like something dot X, something dot Y, an invisible point reference, and that's called the implicit parameter. And that's just you don't have to memorize this, it's just kind of useful information. It's like the object being acted upon in an instance method. So which X, which Y? Well, it's the current X, the current Y. That's the implied parameter. Instance methods break down roughly into two groups. The first group is methods that will modify the internal state of an object, and those types of methods, we call them mutators because they mutate. You can recognize them very often because they begin with the word set. So if you had some sort of like a thermometer, or that's not a thermometer, like a thermostat object, and you wanted to be able to set the temperature, you might have a method that said set temperature, and that you would understand, oh, set temperature, that's probably changing something inside the thermometer object, or I keep saying that, the thermostat object, so it's a mutator. And they very often don't have a return type, so the return type will often be void because you're just writing internally, you're not getting a value. Accessors are the second type of method on an object, and they will typically, or second type of method on a class, they will typically just access the internal state of an object. They won't write to it, they'll just like either directly report the internal state of the object, or they might perform like a mathematical calculation based off of the internal state of the object and then return a value. So they very often do have a return type. In fact, they better, or else they're not really accessing anything. And they often begin with these words get or is. So going back to our thermostat class, if we had a thermostat object and we wanted to get the current temperature, then you would have like a get temperature, and maybe you wanted to allow people to get the temperature in Fahrenheit and Celsius. Well, you'd have two different ones: get Fahrenheit, get Celsius, or however you wanted to name them. But they would probably begin with get, and then inside the bodies they might perform like the mathematical operation for like applying the formula for converting Celsius to Fahrenheit and vice versa. But they would just be reporting the internal temperature; they wouldn't be changing it. Okay, so here's an example of an accessor method, and this is on our point class definition that we've been working with. So imagine like we wanted to figure out the distance of the current point from origin, and origin is 0, 0 on a coordinate system. So how do we do that? Well, you can imagine it being like a triangle where you have A, B, and C, and we just use the Pythagorean theorem where we take the square root of the sums of the squares of the two of A and B, and yeah, so that's how we could get it. And you can see that we're performing that mathematical calculation here using the built-in Java math class. It has that square root function, so we don't have to write it ourselves. So we're not directly reporting what X and Y are, but we are accessing X and Y here, performing a calculation, and then returning that value as a double. So this is an accessor. We're not modifying the internal state. It's not a mutator. Okay, so mutators, accessors, we've talked about fields, we've talked about the methods, and now it's time to talk about constructors. Constructors, we've dealt with them in the past. It's how you create an object. And there are some kinds of objects that you don't need a constructor for, like strings. There's a special syntax for creating strings where you don't have to use a constructor. Likewise for arrays, there's that special syntax for creating an array. But most of the time when you're creating an object, you're going to call a constructor. And so it's time for us to define a constructor for our class. So going back to our point class, and here is the constructor for it. And the constructor is a special method, but it doesn't have a return type. So our definition right here for our point constructor, there's no return type here, because the return type and the name of the method are the same. So the name of a constructor method is the same as the class. And that is also its return type. That's why there's only two words here, rather than like in a different method declaration you'd have three. They can accept parameters. In fact, they very often do, and they will initialize. The job of a constructor is to initialize the state of the object. So after the constructor finishes executing, you'll have a new object from this point class, and it will have its x and y set to the initial values. And you can see that the parameters that we accept here for our declared or for our defined constructor is an initial x position and an initial y position. Okay, so that being said, there are some pretty common mistakes you can make when you're creating constructors. Here is one of them. This is a perfectly valid code. So this will compile and this will run, but it's not going to do what you think it does. So you can see here that I've added a void keyword right here. Void means that typically, well, when you use it with a method, it means that it's not returning anything. If you add void to a constructor, you've now created not a constructor. This is now a method on the point class. And so you couldn't call this as a constructor, but you could call, if you had like a pre-declared P1 like point object, you could call P1.point with a capital P now, because that's what we've defined. We've defined a method on the point class named point, and then we call them initial x and initial y, but that's not what they are anymore. You can call this as many times as you want, and anytime you do, you will modify the internal x and y of this current point. So yeah, don't declare a return type. Don't even put in the void keyword as your return type. The second very common type of constructor error to make when you're first starting out is to accidentally redeclare the fields. So this doesn't, when you look at this code, it's not obvious what's wrong. This also will compile like the previous slide, and it will run, and it'll be really confusing what's going on here, because the mistake is that I have redeclared x and y. I don't want to declare x and y variables inside this constructor, because when I'm writing the initial x and y, I want to write them to these variables up here, the point class fields. I don't want to write them to these two variables, because these are variables that I've created only inside the constructor, so they die at the end of the constructor execution. So what will happen if you create a new point with, we'll say it's like a point with 1 and 1 for initial x and initial y. So it enters this constructor, and we create a new x and we assign 1 to it. We create a new y and we assign 1 to it. And then the constructor finishes. But because we've written to this x and y and not this x and y, the point will always be 0, 0. Yeah, that's not at all what I was trying to do here. So don't do that. Don't accidentally redeclare your fields. You only have to set the type on a variable when you're initially declaring it, not when you're assigning a value to it. Okay, so back to the previous, it was several slides ago when I was creating a new point object, and I had this line of code where I said point p1 equals new point. So I didn't declare a constructor for my point class when I initially wrote it. How did this work? And this would work if you went back and compiled that very first definition of the point class that I gave you on that slide and ran it. You could create a new point object. And the answer is that if you don't create a constructor for your class, then Java will put in a default one that accepts 0 parameters. And it'll create a new, if you invoke it, it'll just create a new object where all of your fields have the default values. But if you do create a constructor, then the default one goes away. So on my previous slide where I have this point, well, I guess this is the bad one. This is the good one. So if I was to create this constructor or add this constructor to my point class, I can no longer say point p1 equals new point. Every time I create a new point, I have to pass in an x and y, because Java says, you've got a declared constructor, I'm going to delete the default one. Or I guess more precisely, it just won't add it to your class. Okay, cool. Moving on. So let's talk about a concept called encapsulation. But in order to get to that, we first have to talk about this idea called abstraction. Abstraction is focusing on like your class's essential properties, while you're hiding like the details, the nitty gritty on the inside. And encapsulation is when you hide the implementation details of an object from the clients of the object. So, in order to encapsulate stuff, we generally make it private. Up until this point, when we've been declaring methods and classes, we've been using the public keyword. And that has implied that there's some things that exist that could be not public. And that's true. There are things that exist that can be private. And in general, when you're creating data fields, you should make them private. And so here's the redefinition of our point class once again, where I am saying that these fields exist, int x and int y, but I want them to be private now. And just for kicks, I am assigning default values of 0 to each one of them. You don't have to do that. Like I said, if you don't assign a value to them initially, they will have the default value. And for integers, the default value is always going to be 0. But, you know, it's kind of a good thing to show what the default value should be, at least, even if it's 0. Private data fields. So yeah, as I said on the previous slide, data fields should be private. You should make them private. But if you do make them private, then it's no longer possible for clients to access those fields, those x and y fields on our point class. Like, those are private. If you try to do that, then Java will just crash. Well, it actually won't even compile. It'll say, like, no, these are not visible to you. They're only visible inside the class. So yeah, why would how do I deal with this new situation where my fields aren't visible outside the class? And the answer is that we use methods that access the internal state of the object. And as we said before, methods that access the internal state of an object are called accessors. And so I've added 2 new accessors to our point class, where we can get the x and y values, and that is why they're called getX and getY. These very simple versions of accessor methods are sometimes called getters, where you just get the internal variable. And generally when you're writing a getter, it'll be like a single line. There might be some debug code in there, but very often it's just like a single line where you return the field. And then if you want to allow someone to modify the x and y values, instead of like p1.x equals 5 and p1.y equals 2, you could create, and I have on this slide, create a mutator method that allows clients or users of your code to write to the x and y. And so I have like a shiny new mutator method where I allow people to write to the x and y of the point using parameters that they pass in, where you pass in a new x and a new y value, and I just overwrite the current x and y values with whatever's passed in. All right, so also important details. Constructors can call methods. So if I have declared the setLocation method, my constructor can now call the setLocation method. Instead of writing directly to x and y, I'm writing to x and y in the setLocation method. So let's just call it from the point constructor. And you should do this. You should, if you have a special method for writing to the state of your object, you should use that method as much as possible, so that if you ever change the way that things are written to the inside of your point class, you would only have to modify it once in the setLocation method, rather than looking through the entire class definition for every place where you've said x equals this or y equals that, and then like having to update the code in multiple places. If you always use the setter or the mutator methods, then you can reduce the number of places that you have to change when you want to make modifications like that. Methods can call other methods. So you remember that translate method that I had earlier, where I was writing directly to x and y. I can now use setLocation instead of writing directly to x and y, where, okay, so I have delta x and delta y. So what do I set it to? Well, I just modify x by delta x, modify y by delta y, and pass it into the setLocation method, and then it will take on the responsibility of modifying the internal fields. Okay, class variant is not a concept that you have to memorize. This is not like a a word that gets thrown around a lot, but the concept at least is useful to understand, and it's sort of a conceptual statement about an object that needs to always be true as long as the object is alive. So if I had a coordinate system where maybe I was drawing on a screen, like points on a graph or something, and I wanted to display it on a screen, and the bottom left hand corner of my screen was 0, 0, and as I went to the right, X would get bigger, and as I went up, Y would get bigger, then it would make no sense in that sort of system to have negative point values because they would be off the screen. And so I could create this enforcement in the setLocation method where if anyone tries to pass in an X or Y that are less than 0, that are negative, then I just throw an exception. So this will be a class invariant. The class invariant statement about this is that X and Y are always non-negative. And again, this is if you remember, I've been calling the setLocation from my other methods and even from the constructor. So if I wanted to make a change like this, I only have to do it in this one place rather than having to check the X and Y values in the constructor and in the translate method. I only have to do it in one place, just in setLocation, because all those other places are calling setLocation. So it gets enforced in one place and it keeps the code nice and clean. Some instance methods just sort of get added to every single object you create, even if you don't write them yourself. And one instance method that every single object has is the toString method. And what its job is to do is to create a string representation of the object. So you can see in the past how we've called system.out.println on different things, and it prints out representations of them. In order for the class that you have defined to do something useful, you should write your own toString method, because the one that gets added by default to your class, to every object that you create from your class, isn't actually very good. It's kind of lame, actually. It'll tell you the name of the object, or the name of the class that the object belongs to, and then it'll give you like what looks like a random gibberish of like letters and numbers. It's actually a memory address. If you want something useful to be done when your object gets printed out to the console or added to the end of a string or something like that, then you should write your own toString method. And when you do, you need to match the definite or the class signature, or you need to match the method signature exactly as shown on your screen, where the name of the method is toString with a lowercase t, capital S, and the return type has to be string, and you can accept no parameters. And what you do inside there is you just create a string that you think is useful, that represents the internal state of your object. Potentially, you don't necessarily have to include all of your fields, just whatever kind of you think would be useful for someone reading your, someone using your class. And so for a point, what's useful in a point? Well, we would want to know like probably just where X and Y are. And so that's what I've done here, where this will print out P equals left parenthesis, and then I'll input, or I'll append to that the value of X, so whatever it is. If X is 5, then a 5 will go here, comma, space, and then likewise for Y. So if Y is 7, then 7 will go here, and then a right parenthesis. So yeah, this is an implementation of the toString method that you could find potentially useful. Another very common instance method to be called is the equals method. If you remember back when we were talking about comparing two objects, you can't use equals equals because that compares just the memory or the references. It won't actually compare like this, the internal state of two objects that might have like the same internal state. If we want to do that, then we have to write our own equals method. And again, just like the toString, if you don't write one, you'll get one for free, but it's not a very good one. So the signature of your equals method has to match what you see on the screen, where it returns a Boolean value that will be true if the object being passed in is equal to the current object and false otherwise. And the type of the it accepts one parameter in the equals method, and the type of the parameter is object. And inside the body of your equals method, this is just a very, very typical implementation. And if you look at this, well, let's just kind of break it down. So you can see here, skipping over this first part here, I'm actually looking at the other points x and y values. And if you remember, I made x and y private, and I said earlier that you cannot see the private fields of an object, right? Unless you're inside that object. Well, I'm not inside that object. I'm inside my own object, but I'm not inside this other object that's being passed in. So how can I see x and y? And that is because in Java there's a special exception. If the two objects are the same class, then you can see the private fields of the other object. And that's the only exception to that private rule. Okay, and the other thing that we should look at in this equals implementation is this instance of keyword. So it evaluates to a Boolean, and the way that it works is that you put to the left of it an object reference. So thing would be some sort of object that exists that's been passed in, and then instance of the keyword, and then you put a class name on the right. So this three-word expression will all evaluate to true if the object named thing is an instance of point. It will evaluate to false if thing is a string, if it's an array, or anything else, it will evaluate to false. And then is point will be false in that case. So going back to our implementation, the implementation of equals, let's go through it line by line. So if, this means not, so whatever's inside these parentheses will get reversed. So if O, so if this other object is an instance of a point, if it is an instance of a point, and then modify that or negate that. So if it is not an instance of a point, then immediately return false. Okay, that makes sense. If it's not an instance of a point, then it can't be equal. So yeah, it's always going to be unequal. So returning false makes sense. If it gets past this line, then it means it is an instance of a point. But the type here is object, so we can't access x and y without first doing a cast. And you've seen the syntax before, this cast syntax, when we were working with primitives. If we wanted to convert a double into an integer, we had to cast it in order to lose that precision and convert it into an integer. So likewise, if we have an object that we want to treat as an object of a different class, then we have to cast it using the parentheses and then the class name of the thing that we're casting it as. Generally, you don't want to cast things without testing whether they are an instance of first. So you'll see this pattern a lot, where if it is not an instance of that class, then return false or bail out of the method. And if it is, then you can safely do the cast. So at this point, this other object is of type point, so we can access its private x and y fields. So if the current x of this current point is the same as the other point object's x, and this current point's y is the same as the other point's y, then in that case, if both of those are true, then they are equal and will return true. Okay, so yeah, moving on to a special new keyword, the this keyword, THIS. This is a special reference. Remember earlier we talked about the implicit parameter? Well, it doesn't have to be implicit. You can make it explicit, and you can actually use the this keyword if you're referring to variables on the current object. So here you see in the translate method that I'm now calling this.x and this.y. That is much more clear than just saying x plus equals delta x or dx. And so I would prefer, I always prefer to use this.x rather than just implicitly using the implied parameter. This is only going to be visible inside the object. It can also be used to access not just fields, but methods. Remember in our point constructor, we call set location. Well, you can call set location by using the this dot keyword in front of the method. I don't find using the this keyword for methods as useful because it just doesn't communicate as much information as I think it does when you're accessing variables. What this is especially useful for is for dealing with shadowed variables. And so I have on this slide here a new definition for the point class, where in set location, the only difference here is that I've changed the names of the parameters that are passed in. If you remember, I think set location used to be new x and new y. If they have the same name, and this is allowed, this is valid Java code that will compile and run. If they have the same name as the internal fields, then they will actually hide the internal fields. So in this case where, skip over this chain, we've already explained this, we're just trying to keep our x and y positive. If I want to write to x, well, the name of the thing that I'm trying to write to it is also x. So what I'm trying to say is take this x and write it to that x, and then take this y and write it to that y. But if I just do x equals x and y equals y, the parameters of this method are hiding the fields because they have the same name. So I'm just taking the value of x and writing it to the same variable. These are these equals assignments are only going to modify these variables here, which isn't very useful. I want to modify these variables there. And that's where the this keyword is really useful. If I just prefix the x here and the y here with this dot, then Java knows, oh, you mean like the this one, which means the one in the current object. So the x without the prefix, that's the one that's the parameter that's passed in. The one with the this dot prefix, that is the x on this current object in the class. Also, another important concept that you see very frequently is that you can have multiple constructors. So going back to the fact that if you create a constructor, it erases the default no argument constructor. Well, maybe you want both of them. Like, so in our point definition, maybe you want to allow people to create points and give them an x and y value, but you also want to allow people to just create a point and then it'll always be at 0. Well, you can do that. You just create two different constructors, and you can have multiple constructors, as many as you like, so long as the signature differs. So constructors always have to have the same name. They're always going to have the same name, but as long as the parameters are unique, then that's fine. So these two accept different parameters. This one has 0 parameters, and this one has 2 parameters, each of which is an integer. So those are unique signatures, so this is perfectly okay. You can call one constructor from another constructor, and you can see that in this slide, that's what I'm doing. And you do that by using the this keyword. Once again, only this time, you use parentheses. So when you see this, this used in a manner such as this, where you have parentheses after the this keyword, that means that it is calling a constructor of the current class that matches this signature. So it has 0, 0, so that's an int and an int. And so you would hunt through the code looking for the constructor that accepts an int and an int. That's this one here. So this constructor will then go to this constructor, which would then go to the setLocation method, which then, as we've seen earlier, will write to x and y for us. That is all I have for slides. So let's move on to the coding example. For the coding exercise, I've come up with a completely fictional game that I want to play, where 3 robots are working together in a team to score points. And there's a criteria for scoring points. And this is the sample output for the program. So I want to ask for the team name, and ask for a robot name, ask how many game pieces the robot scored, ask for a row and column, because the game pieces are going to go into an imaginary grid that has it's going to have 3 rows and 9 columns, and then I'm going to repeat that for each of the game pieces. So yeah, when after I've asked how many game pieces, that's how many times I'm going to repeat. And then I'm going to ask if the robot is docked and engaged, which is a special configuration that scores lots of points. And then if not, I'll ask if it's docked, and then I'll ask if it's parked, and assign point values for each one of those. I'm going to repeat that for 3 teams. And then at the very end, I'm going to say how much each robot and corresponding team scored, and then add it all up for the total score for all 3 teams. So this is a modification of a very popular competitive game where I have eliminated link bonuses and other things like that, the autonomous phase entirely. But yeah, maybe you're familiar with this, maybe not. In any case, let's code it up. So let's think about this. Let's write some pseudocode initially, and let's only do the first step. In fact, let's just do this right here, these first 2 lines here. Get the team name and the robot name. So I can actually just copy that because those are the strings I want to do. And I'm going to go to this chargedup.java, which I've already started here. Let's start off by getting the team name and the robot name. If you look at the sample output, it looks like once I get the team name and the robot name, I keep them roughly together. So I refer to the robot name here 3 times, and then at the end I refer to the robot name with the team name. It looks like a robot, if I'm thinking about this in an object-oriented way, a robot at least has its own name and it has a team name. Let's create a method here, and we'll call it get public static something. We'll say robot, get robot. And we're going to, on this method, accept a scanner object. The scanner is just, as I said before, it's a way to get input from the user. So we want to get a robot name. and then a team name. Actually, if we refer back to this, I think we want to get the team name and then the robot name. So let's do break it down to pseudocode. So get team name from user, get robot name from user, and then return a new robot object. Okay, so we can get the team name from the user using the scanner object. We can actually just do it by doing this. Oops. And we can do the same thing for the robot name. But we want to ask the user for that. So when we say get team name from the user, we probably want to add a step here where we say ask user for team name. And we want to ask the robot, or ask the user for the robot name too. And how do we do that? Just by outputting a string to the console. We've seen this very common set of, or this very common line here. We go system.out.println, and then we pass in a string. So what's our string? Well, our string is going to be what is team one's name. Now we're going to have to modify that to be team 1, team 2, and team 3. But for now, let's just do it like this. And here where I have the team name, I actually already have the team name right here. So I can use the string concatenation syntax where I add to, well, I'm actually adding 3 strings together. I start with this what is space string, and then I add the team name, and then I add apostrophe s, and then the robot named question mark. Okay, so I think this will work. Let's try it out. We'll create a scanner object. And if you're curious, if I use the system, oh man, that doesn't look right. There we go, system.in, that should give me a scanner pointed at the console input. And then I want to say robot, first robot, whoops, it's going to be one word. Well, first robot, second robot, and third robot equals get robot. And then we'll pass in the console. All right, I will save this and we will compile it. Java C charged up Java. Okay, so what's the problem? The problem is that we cannot access robot. That is because we have not created the robot class yet. Well, I have a robot.java file, but we haven't defined a class. So let's create the class. There, done, right? We've created the class. Well, sure. In fact, if I compile this, I need to compile the robot one first. This will almost work. Oops, missing return statement. That is because I get the 2 strings here, and now I need to create the robot. So what goes into creating a robot? Well, a robot has a team name and a robot name. And so if we go to our robot, we're going to have some private fields. These are going to be private string team name, and then private string robot name. Okay, and then we will have a public constructor. Remember, constructors don't have a return type because the return type is basically their name. The name and the return type are the same thing. And what are we going to do? Well, we need to accept a team name object and a robot name object. So I can actually just copy and paste those in. So team name and robot name, those are objects because strings are objects. So I accept these 2 parameters. And then inside my constructor, I initialize my internal state. So I use this keyword this dot team name, and then I want to assign to this team name the parameter also called team name. All right, let's try compiling robot again. Robot compiles, and we don't need to bother compiling charged up yet because we still haven't returned the robot. So how do we return the robot? Or how do we create a robot? Well, we're going to return it, whatever it is. So we create the robot by using the constructor syntax, the keyword new, and then we use the class name because that's the constructor name as well. And the constructor that we just defined takes in two parameters, the team name and the robot name. Team name first, so we'll pass in team name, and the robot name second. All right, let's try compiling charged up. Okay, cool. So let's try running charged up. What is team one's name? We will call them the, let's see, the Flying Toasters. And what is their robot named? Their robot will be named Windows 95,000. Okay, well, did it work? I don't know, maybe. What's a good way to know that it worked? Well, we could try printing out our robot. Yeah, let's add a line right here where we try printing out our robot. System.out.println first robot. Let's see what our first robot looks like. We'll say the team is Greg, and what's Greg's robot named? Greg's robot named is Peck, Gregory Peck. Okay, and so what you're seeing here, this gobbledygook, is the default implementation of the toString method for robot. Because I haven't written in my own toString method, the toString method is just going to be the name of the class, and then this is actually a memory address. So let's write a toString method that would actually make sense here. So the toString method needs to match this signature, public, and the return type is string. The name is toString, capitalization matching exactly that, and then no parameters. And now inside this, I just simply need to create any string that I think represents my robot. So I'm going to return, I'm going to say robot string is going to look like this, robot, and then we'll have parentheses, and then maybe I'll say team equals, and then I'll put the team name in there. And then I'll have comma, name equals, and then I will add the robot name. And then I will close the whole, I'll close the whole thing out with a right parenthesis. Let's see if that works. I'm going to have to recompile robot. And I shouldn't need to recompile charged up because I haven't modified that code, so I'll just run it. What is team one's name? The buzz saws. And the robot's, we'll say Fluffy. Okay, cool. So the team is the Buzzsaws, the name is Fluffy. Cool. So it looks like what I did, my code actually worked. So first things first, I've got these two lines mostly done. How many game pieces did it score? Well, should I do that first or should I, yeah, let's go ahead and do that. We'll do this multi-step process here where we ask how many game pieces were scored and then the row and column for each piece. So looking at this guide here, or looking at this sample output, I know that a game piece is going to have a row and a column. And what else does a game piece have? Well, it's not really captured in this output, but I do know that just from the rules of the game that when I want to total up the points depend on points are going to depend on not the column, but the row for where the game piece went. So if the game piece was in row 1, I get 2 points, and then if it's in row 2, I get 3 points. But if it's all the way in row 3, I get 5 points. So I think I'm going to need to keep just the row and the column on the game piece, and then I can use the row and the column at the very end to get the points. Or I guess, as I just said, the row matters for the points, but not the column. Okay, so let's go over to my game piece definition, and now it's blank. It's just an empty file, but we can create a class really easily. Public class game piece. All right, whoops. All right, so there's our class. What does a game piece have? Well, it has an int, it has a row, and then it's going to have a column. And then we're going to have a constructor. where we have a row and a column passed in. And then I'm going to want to initialize the row and the column. This dot row, and then assign to it the parameter named row, or the value of the parameter named row. And then do the same thing, this dot column, this one right here, and assign to it the value from the parameter column. Okay, and I'm going to assume that I will want to do something very similar for printing out game pieces just to be safe. So the signature should be the same, but I'm going to need to print out different stuff. So the game piece, well, I'm going to probably print out the row, and then I'm going to want to print out the column. Okay, cool. Now I know at the very end, I'm going to need to get the score for each game piece. So let's create an accessor method. This isn't going to modify the internal state. We're just going to calculate the score based off of the game piece's placement. So the score is going to be an integer, and we'll say get score. What's the score for this game piece? Well, this is going to be a multiple choice. So if row is 1, well, I said if it's in the first row, then we should return 2. That's what the score should be. Else, if row is 2, if it's in the second row, then it's going to be 3 points. And then in the final, I could check if it's in row 3, but I know if it's not in the first 2 rows, then it's got to be row 3, right? Return 5. Now, I said if it's not in the first 2 rows, then it's got to be in row 3, but that's not actually true, right? If I look at my code here, game piece has a row and a column, but the person creating or accessing my code here could pass in any integer. In fact, they could pass in negative rows and negative columns, and that's not something I want. So I'm going to put a check up here. I'm going to say like if, and then I'll have like some condition, like if something's not true, then I'm going to throw a new illegal argument exception. And so we'll have a check in here for invalid rows and columns. So what's invalid? So, well, I know if the row is less than 0, then that's definitely invalid. I know if the column is less than 0, then that's definitely invalid. Okay, what's also invalid? Well, I know if the row is greater than 3, because I know there's only 3 rows, right? And I also said earlier, if you remember, that there's only 9 columns, so if the column is greater than 9. Okay, so this should account for all cases here. If the row is negative, or if the column is negative, or if the row exceeds 3, or if the column exceeds 9, then no dice. You don't get a halving game piece. That's you put that in some invalid place. And now I don't need to account for any other rows here because I've already enforced at the time someone creates a game piece that it's either in row 1, 2, or 3. So I know if it's not 1 or 2, then it's got to be 3. All right, let's try compiling game piece just to make sure I haven't made any obvious errors. Oh, and I have. You probably noticed this. I didn't make this one on purpose. I wasn't trying to trick you or anything. I left off a type in my parameter for the game piece. Probably shouting at your screen. Okay, great. So it looks like game piece probably works. Let's try it out. So what do? We say how many game pieces did it score? So we have this getRobot method. Let's have a public static. What are we going to get? We're going to get a bunch of game pieces, right? Let's get a bunch of game pieces. Let's get an array of game pieces. Game piece array, not pieces. Game piece array. That's our return type. Get. Let's say game pieces. And we are probably going to have to pass in a scanner object in order to continue to get input from the user. Okay, so what are we doing here? Well, we want to ask for the number of game pieces. And then what do we get the number of game pieces? Get the number of game pieces. And then we want to ask for well, we want to do this process. So we want to ask for the row for each game piece. So this is going to be a for each loop. For each game piece, ask for the row, get the row, ask for the column, get the column, and, well, what next? Well, we know that getting a row and a column isn't really useful. We want to get a game piece, so we actually want to create a game piece object, and then we want to do what? Well, we know that we want to get an array of them, so we would want to put it in an array, but we haven't created an array. If you remember from our previous lesson, arrays you can't change the size of an array. Once you create it, it's fixed. And so at the time that we created our array of game pieces, we have to know the size or the number of game pieces that we're going to collect. And if you look through our pseudocode, we know at what point we have figured that out. It's at this line right here. So after we've gotten the number of game pieces, we can create a game piece array. Okay, and after we've created the game piece object, we can add it to the array, and then at the very end, return the array. All right, I think we can convert this into pseudocode. So let's start for asking the number of game pieces. So how many game pieces did it score? Gosh, okay. So we're going to ask how many game pieces it scored, and then we know how to get the number of game pieces. Well, actually, we don't. This is going to be a little bit new. Number equals, we can actually just call console.nextInt. Okay, and that will give us the next integer that the user running our program enters. All right, so at this point, that's getting the number of game pieces. Great. Now we want to create a game piece array. We know how to do that. Game piece array game pieces equals new game piece array, and the size is going to be number. Right? And this is an object array, so that means that when we create it, the array is created. It's got entries equal to to this number that's passed in, but all of the slots are empty. There's no default value, so we need to go through and we can convert this line of pseudocode pretty easily for each game piece. So we know how to go through an array. Int I equals 0, I less than game pieces dot length, and then we will go I plus plus. That will take us all the way through the game pieces array. So now we're inside the creation of that, we're inside the loop here. We're going all the way up to the number of game pieces. So for each one of these, we want to ask for the row. How do we ask for the row? By just outputting, copying and pasting the code. All right, and then we can later on do this. Just let me put a couple spaces in there because we haven't quite got to it yet. So we've asked for where it goes, but we need to get the actual number. So int row equals console.nextInt. And then, I zoomed, oops. And then we ask where to go, or which column did it go in. So we can say int column equals console.nextInt. And then at this point, we've got the column and the row, so we can create a game piece object. And we know how to do that because we have defined this constructor. So going back to our game piece Java file, we can see that we take a row as the first parameter and a column as the second parameter. So let's take the row and the column because we've created those, or we've gotten those two values. And now we want to add it to the array. Well, where do we put it in the array? Well, we put it at the index I. And so it could be that we just do this. Game pieces at index I equals, equals game piece. Or instead of doing this in two separate lines, declaring variable and then immediately assigning it, you can just do that. You can say that in the array called game pieces at index I, put in a new game piece object with the row and the column. All right, and then after our game pieces finishes, or after we've populated the entire array, then we can return the entire array. Let's try compiling this. Oh wait, that should already work. And no syntax errors. Let's go to, okay, so we don't need this line anymore. Get game pieces. Console. Yeah, let's try printing them out after we get them. We already know that, like, when we were writing our getRobot method, we weren't sure if it was done or if it did the right thing, and the only way we could verify is by printing out that robot object. In this case, we have an array, so we're going to have to go through the entire array. And this time, I'm going to use the for each syntax. So for a game piece in game pieces. So if you remember the for each syntax, this means for each game piece, so this is the type, name, and I give it a name here, game piece, within, that's what the colon means, this array, do what's inside the body of this for loop. So I'm just going to print out that game piece. Let's try compiling again. Uh-oh. It looks like game pieces, I keep doing this mistake. Game pieces is not a class. Game piece is the class, and game pieces is the name of the array. All right, let's try running it. What is team 1's name? We'll say they are the Boogie Men. What is their robot named? Their robot name is Clyde. How many game pieces? Well, it only scored 2. In which row did game piece 1 go? We'll say it went in the 3rd row, and it went all the way on the right, in the 9th column. Okay? In which row did game piece 1 go? We'll say it went in the bottom left, so it's going to be 1 and 1. All right. Okay, so it looks like it re-outputted the values that I passed in just fine, but you can see that I'm asking the same question over and over. In which row did game piece 1 go? In which row did game piece 1 go? Well, that's because I have, in my get game pieces method, I just blindly copy and pasted in which row in which column, so I'm using the same name each time. So, this is pretty easy to fix. We just use our string concatenation syntax where we're adding 2 strings together. And what does a string in the middle, or what should the actual number be? Well, we don't want to use I, because I is going to be like 0. It's going to start at 0. So we're going to say, if we use I, then it would say, in which row did game piece 0 go? We don't want that. We want 0 plus 1. And I'm just going to copy and paste that same thing right here. Okay, oops, put a space in there. Okay, so that should take care of that bug. So we've got game pieces. What comes next? Is it docked and engaged? Is it docked? Is it parked? And then we'll have the repeat for each team. Okay, so we will say, what should we call this? We'll say get game end score, I guess. Yeah, I think that works. Get game end score. And I think I'll just say get game end score is going to be a method that returns the score itself. So I'll say int end game score equals get end game score. And I assume I'm going to need another. All right, I'm going to need this console object in order to keep reading the user input. All right, so public static int get endgame score Okay, so here's the fun thing. Let's do this in pseudocode. So the first thing we're going to ask is the robot docked and engaged? So first of all, we know we need to have the robot name. So we should probably change our signature here. We need the robot, because the robot object has the name inside of it. If we go back to our code here, yeah, the robot name's right there. So pseudocode ask if it's docked and engaged, and then get. And this is going to be the same thing, only we're asking slightly different stuff each time. So first we ask if it's docked and engaged, and then we ask if it's engaged, and then we ask if it is parked. And then at the end we want to return the total score. Well, how do we know the total score? Well, we can keep a running tally here. So get if docked and engaged. So we can say if so add how many points is it for docked and engaged? For docked and engaged, it's going to be, we'll say arbitrary number, let's say 10 points. And if it's only engaged, then our arbitrary number is actually not going to be 10, it's going to be 6 points. And if it's only parked, then we're going to add a total of how many points? We'll say 2. Just spitballing here. Okay. This is something that we can convert to code. So let's copy our string. Oops. And our robot name is going to be robot dot. Okay, well, let's see here. It's going to be dot robot name. Oh, but we can't get the robot name because it's private. So it's time to add an accessor or a getter. Public, this is not a static method. This is an instance method, so we leave off the static keyword. And the robot name is a string, so it's the return value. Get. Let's say get name. And we don't need to do any calculations here. We just return the robot name. Get name. All right. And we can actually just, it's going to be the same thing, just slightly modified each time. All right, so we now need to get is docked and engaged equals engaged. Okay, get, and that's this is the thing I told you to ignore earlier. We're going to say get Boolean. Oh, we've got to pass in the console. And we'll do the same thing for the rest of these. Oh. That's weird. Okay. And so what comes next? Well, what comes next is that we need to be doing these steps. So if so, add 10 points. Add 10 points to what? Well, we probably want to declare a total end game score initially. Int total end game score. And we'll say it's 0. If it's docked and engaged, then we want to total end if is docked and engaged. Only if that's true, then do we want to say total end game score plus equals 10. And we're going to do a very similar thing for all 3 of these. Only we're going to be checking a different condition here. We're going to be checking is engaged, and we're going to add, instead of 10, we'll add 6. And then here we'll check if it's parked. And in that case, we will add 2. Okay, I think this is good enough to test. Let's try it. I'm not going to need that code anymore. But let's print out our just for testing purposes. Okay, so remember we modified robot, so we need to compile robot again, because we added that method for getting the robot name. And we also need to recompile charged up. Uh-oh, it looks like, okay, method get endgame score and class charged up cannot be applied to the given type. Okay, because endgame score, remember we modified the signature to accept a console and a robot parameter, and I only am passing, whoops, let's look right here, I'm only passing in the console, so I need to pass in the robot parameter, and I have it right here. It's first robot. Try again. New error, missing return statement. Okay, that is probably because in my get endgame score, I total up the endgame score, but then I never bothered to return it. Again, you were probably shouting at your screen. Whoops. All right, great. Let's try running it. There should be, I think there's going to be an error here, but we'll check. Team 1's name, we'll say coffee. What's the robot? And the robot is definitely named Bean. How many game pieces did it score? It scored, oh man, it scored 4 whole game pieces. Well, so first, which row did game piece 1 go on? It went in row 1, and it went in column 1. In which row did game? Well, it went in row 1, column 2. And then the third piece, well, guess what? It went in row 1, and it went into column 3. Uh-oh. Now I'm going up to game piece 4. Oh, I did say 4 game pieces. Okay, so this one went in row 1 again, and column 4. Great. Now, is being docked and engaged? Is being engaged? Yeah, this is a subtle bug. This is related to scanner, and I'm just going to kind of gloss this over. I'm pretty sure this is, you're not going to have to worry about using scanner, but there's this weird little gotcha the way that the next, okay, so I think what I need to do is in here, I need to call console.next line to move to the next token. Yeah, ignore that. That's kind of a little subtlety of using scanner that doesn't really concern the stuff we've learned today or the stuff that we want to learn. Okay, charged up. What is team 1's name? We'll say coffee. They've shortened it. Bean, 4 game pieces. 1, 1, 1, 2, 1, 3, and then 1, 4. Okay, is it docked? Is being docked and engaged? Yeah, it is docked and engaged. Awesome. Is being engaged? Well, yeah, I guess so, because it's docked and engaged. Is being parked? Well, yeah, I guess so, because it's docked and engaged. Okay, so the score is 18. Is that what we expected? Well, if it scored 4 game pieces in the first row, then it should get 8 points. And then if it scored, if it was docked and engaged, then it should get an additional 10 points. So that's 18 points. But is that what we wanted? Hold on. Well, yeah, it is actually what we wanted, but we've got to, okay, this is why I'm confused. If you look at charged up, I'm only getting the endgame score here. I'm only printing out the endgame score. So let's run it again with different input. Oh, that's weird. Let's run it with different input to actually make the bug visible. Okay, what is team 1's name? Coffee, misspelled. Bean. How many game pieces? 0. Oh, sad. Okay, is it docked and engaged? Yes. Yes. Is engaged? I guess so. Because it's docked, it's got to be engaged. Is it parked? I guess that qualifies as parked. The score is 18. Well, that is definitely not right. We know if it scored 0 game pieces and it's docked and engaged, it should be getting just 10 at the end. And the bug here is that I'm asking these three questions. I should only be asking, like, if a robot is docked and engaged, that's it. They don't get extra points for also being engaged and also being parked. So let's go to our get endgame score. And what I want to do here is that if it's docked and engaged, then I want to do this. And otherwise, I want to do this. And then otherwise, I want to do this. And so, yeah, what's a better way to do this? I want these to be mutually exclusive. Well, what I can do here is that I can actually return early. So instead of keeping a cumulative score here, I can actually just say if it's docked and engaged, I can just return. Because I don't care about anything else after this point. They get 10 points, period. And if it's engaged, then I can just return 6 points immediately. If it's parked, then I'm going to return 2 points. And if none of those are true, then I'm going to return 0 points. Okay, let's try rerunning our code. Well, I need to recompile it. And then rerun it. Coffee, bean, 0 game pieces. Is it docked and engaged? Yes, it is. Okay, 10 points. Great. Let's try running it again. And let's say that coffee this time also scored 0 game pieces, but it is not docked and engaged. But they are engaged, so they should get 6 points. Cool, 6 points. Let's try again. It scored 0 game pieces. It's not docked and engaged. It's not engaged. Is it parked? Yes, it's parked, so it should get 2 points. And let's try our very last case, where in this case, even though it scored 0 game pieces, it's going to score a big fat 0. It should score a big fat 0. Not docked and engaged. Not engaged, not parked. Poor Bean. Bean broke down. And Bean got 0 endgame points. Bummer. Okay, cool. So that after we've collected the team name, the robot name, game pieces, and the score, we're going to repeat at the very end of that for each of the 3 teams. And then afterwards, then we want to print out each team's score and in order. And then we want to total up their scores for an alliance score. Well, what can we do here? Well, we could actually associate the score with the robot. So let's create, because at the end of this we'll have 3 robots, and each robot can have a score inside of it, like this. Private int game score. And when we start out, we'll say that the game score is 0. We want to initialize our game score to 0. And we will want to have a method here for public void. This is going to be a mutator method. We're going to add a score, or actually we're going to add a score for game piece, and then we'll pass in a game piece. And if you remember, when we wrote our game piece, we have this score method on it, or this get score method on it. So when someone passes a game piece into this robot, and they say add this to your current score, we can just say this dot game score plus equals game piece dot get score. All right, so that works. Now at the very end, we're also going to want to add an end game score. So we already have a method for getting an end game score. We can just add a method called public void add end game score. And then this will just have an end game score. And the same thing. We will just plus equals, but we're going to add the end game score this time. What do we do now? Well, let's refer back to our sample output. So we've kind of captured all of this up to this point, but this is the part that we haven't gotten yet. We want to repeat this this initial like 3-part step that we've done so far 3 times, and then we want to output the score 3 times, and then we want to output the total alliance score. So going back to our main method here, So we have the robot, the game pieces, the end game score. We want to do these three things 3 times. So, well, let me do some pseudocode first. First of all, we can get rid of this. We're no longer testing that. So, for each of 3 robots, get the robot, get the score, and then output the score. And then afterwards, so this is outside the for loop, output total score. So we already have like these two roughly. We know how to get the robot, or we've gotten the robot and the score. Let's combine those together, or let's combine the game pieces score. We can total that all up with the end game score, and then we will output the score for each robot. So okay, right here for we're going to create an array of robots here. Okay, so inside of our for loop, we're going to be populating an array of robots. Outside of our for loop, we need to actually create the array of robots. So robot array, we'll call it robots, and we'll create a new robot array. And its size is going to be 3. Great, and then for each of these, so for int, let's see, I don't know, I'm not sure we'll need the index. Well, actually we do need the index for one important detail that I'll get to in a minute. So I don't want to use the for each syntax, I want to use the syntax, the regular for loop syntax. So we start at 0, and then we'll go through the array, and we'll use the array length. All right, and our first step is to get the robot. And now when we get our robot, what we've been doing up until this point is we use just like team 1, and we've been saying team 1 over and over again. So we don't want it to be team 1. We want it to be, we'll pass in a second parameter that will be the number that we want it to be. And then here, we'll just use that number. So it starts at 0, and we add 1 before we pass it into the method. So the first robot's going to be number 1, second one will be 2, third one will be 3. Great, and then afterward we have a robot. So we probably want to add the robots to our array. So we will say and we don't need this, we actually don't need this extra variable here. We can actually just create the robot and put it directly into the array. Later on, when we need to refer to that same robot again, we can just get it from the array using the same index. So it's the same, I hasn't changed from here as it is, our I has not changed when we write to it to the time of this iteration when we're reading from the array. So it's going to be the same robot object. Okay. Okay, so we've got all the game pieces, and now we need to go through all of those game pieces. So getting the score is a multi-step process. We want to go for each game piece, add the game piece score to the robot score, and then after that we want the end game score, get end game score, and then we want to add the end game score, add end game score to robot, and then we want to output the robot score, and then we want to output the total score. Okay, so we've got those game pieces. Now we need to go for each game piece. And in this case, I think we can use the for each syntax. And if you remember, our robot has this add score for game piece. So we're going to say robots I dot add score for game piece, And then at the end, we actually don't need to create this variable. We want to do the same thing. Well, we don't want to call add score for game piece. This time we want to call add endgame score. So just like so. And then at the end, so we've now taken care of for each game piece, add the game piece score to the robot, get the endgame score, add the endgame score. Now we want to do this, output the robots. If you look right here at this entire line here, we have the robot name and the team name and then the score. All three pieces of this information is inside the robot object. And so what we could do is just create a string inside of this object and output it. And we could have a method on the robot that does it for us. And we'll call it print robot score. And we don't need to pass any parameters in because everything inside this string is actually inside the robot. All right, so the robot name, it's just this dot robot. And then the team name is just this dot team name. And then the points, likewise, is just the this dot game score plus points. And this is a really long line of code. It's wrapping just because of my text editor. You can see if I make it wider, it almost fits on one line. It's a little ugly, but we'll live with it for now. Eventually, we'll talk about maximum line length and how to break these into multiple lines. But for now, this is going to be just fine. And then going back to our back up to our charged up Java file, and we want to output the robot score after. Let's see, we want to output it after we've collected all of them. Yeah, so after this loop, then we want to go through those robots in our robot array. This time we can use the for each syntax. And we will just say I want to call for each robot and give it an individual name, robot. Within the collection, the array called robots, we will say robot dot, and our new method name is print robot score. Print robot score. Okay, so what did we modify? We didn't modify game piece, we modified robot, so we need to recompile robot. And it's got a problem. Okay, public void add endgame score identifier expect. Oh, I've made an embarrassing typo again. Public. You've been laughing at me this whole time, haven't you? Okay, and then charged up .java. Okay, and let's run it. What is team 1's name? We'll say it's coffee again. What is a robot? Bean. How many game pieces? Unfortunately, Bean is still broken. No, and no. What is Team 2's name? Great, so it's Team 2, it's not Team 1 anymore. Team 2's name is going to be Team Taco Cat. Or how about the Taco Cats? And what is the Taco Cat's robot named? Well, they've named their robot Demon. And how many game pieces? It scored 1. And it scored it all the way up in the 3rd row, in the 5th column, and is it docked and engaged? It sure is. Okay, so just doing a quick little check there. If it's docked and engaged, that should be 10 points. If it's scored in row 3, that should be an additional 5 points. So we're expecting 15 for that one and 0 for poor Bean. Team 3 is going to be, let's see, Skeletor. Team Skeletor. And what is Skeletor's robot named? Well, we'll call it Earwig. How do you spell earwig? Is it with an H? I don't know. I think it's earwig without an H. How many game pieces? It scored 3, but they were all in we'll say the 2nd row. So the second row, first column, second row, second column, second row, third column. And it is not docked and engaged. Well, actually, we'll just say yes, it is docked and engaged. All right, so if it scored, so yeah, like I said, we expected 15 for the Taco Cats. For Skeletor, did we expect 19? Is docked and engaged, that's 10. And then we said it scored 3 game pieces in the second row, so that's 3 points each. So yeah, it should be 19. And poor Bean, Bean from Coffee scored 0 points. All right, I think that is good so far. We've got one last missing step. We want to get the total of all of them. So that's just this. The total alliance score was a certain number. And now what we can do here is we probably want to keep a running tally as we're going through the robot list and then output it at the end. So here's where we print the total score. The total alliance score was, and we will call this an integer called total score. We haven't declared it yet, so let's declare it before the loop. And we'll add to it in the loop. Int total score equals 0. Whoops, not minus 0. Equals 0. And then every time we process a robot, every time we print the robot score, we want to do total score plus equals the robot.get score. The only problem with this is that robot, I don't believe we've added a get score method to it just yet. Public int get score. Let's change the method name to get game score just for consistency's sake. All right. And we'll go back to charged up and we'll say get game score. Okay. Let's try this one more time. And because we modified robot, we need to recompile robot. And ing. I did another typo. Int. All right, and then we need to recompile charged up. No errors there. Let's run charged up. Team 1's name. It's still Team Coffee, and their pit crew has done wonders, and it is back in the game. Coffee did amazing. It scored 9 game pieces. Unfortunately, they were all in row 1. So we'll say it's in, row 1, column 2, row 1, column 3, row 1, column 4, row 1, column 5, row 1, column 6, row 1, column 7, row 1, column 8, row 1, column 9. Whew, is being docked and engaged? No, is not engaged. It was too busy scoring, but it did manage to get parked again. So let's do a quick little mental check there. If Bean has scored 9 game pieces in the first row, that should be 9 times 2. That's 18 points plus an additional, did we say 3 points for Bean? I think it was an additional 3 points for being parked. No, 2 points. 2 points for being parked. Okay, so that's 18 plus 2 should be 20 points total. So we'll just keep that in mind. In fact, I'll put it over here. Bean, we'll say we expect Bean to have 20 points. What is Team 2? We'll say the Flaming Hammers. And what is their robot named? Well, their robot naturally is named George. How many game pieces? Only 2, but it went all the way up into the 3rd row. We'll say the 6th column, and then another in the 3rd row, and it went to the 7th column. So is it docked and engaged? It sure is. And let's do a quick mental check. So docked and engaged, that's 10 points, and then an additional 2 game pieces in the top row should be an additional 10 points. So George should have 20 points. And Team 3's name is going to be the Juicy Fruit Gum brand. What is Juicy Fruit Gum brand's robot? Well, this year they decided to be super funny and to name their robot Null. How many game pieces did it score? It scored 3. We'll say that it scored 1 in each row. So we'll say row 1, and which column? We'll say the 8th column. Yeah, even though Bean already scored 1 there. We'll just ignore that. Which row did game P? Okay, we'll say that went into row 2, column 8, and then row 3, column 8. Is docked and engaged? Sure, we'll say yeah. Okay, so let's do a quick mental check here. How much do we expect them to score? So it's going to be 5 plus 3 plus 2. That's going to be another, well, let's say it's not docked engaged. Okay. But we will say it is parked. So it's parked, so it's going to be 2 points plus, let's see, 5, 3, and 2. So it's 10 plus 2 should be 12. I didn't want them all to be 20. All right, so 20, 20, 12, and adding that all up, 20 plus 20 is 40, plus another 12 is 52. Great. I think that's good. The only change I would make is that we are missing some empty lines here. So after we collect the data right here, we want to print out a new line. And then we would do the same thing after outputting all the scores. And we can get rid of our pseudocode. All right, I think that pretty much sums up all the stuff that I wanted to go over today. How to use classes, how to write them, how to think about them, how to think in an object-oriented manner. Thanks for playing along. In our next session, we're going to move on to, in our next session, we will probably no longer be using this notepad. We'll be moving on to using an IDE, and I'll have, hopefully, I'll have a whole series of videos, really much shorter videos on how to install and use the different software that's specific to doing FRC competitions or FRC programming, and for dealing with the hardware and software involved in that process. Anyways, thanks for watching, and I will see you next time.